Welcome, guys, to this session on consensus in blockchain systems. And this session is organized by Zubi and sponsored by Zinfin Hybrid Blockchain Network. So, in this session, we will talk about various consensus mechanisms in the blockchain systems, like proof of work, proof of stake, and why actually consensus is required in a distributed system. And so we'll deep dive into these things. So before starting, I'll just give you a basic introduction about myself. So my name is Yogesh Agarwal. I am a co-founder at Zubi, where we are building the next generation edtech platform in order to empower millions of students around the world towards new age technologies. Okay, and as a part of it, so we have started a series of exclusive courses and webinars. So you can follow us on any of the social media or join our Telegram community, and you can stay updated on our initiatives. And then I'm a Ethereum Devcon 5 Scholar alumni. So like for those of you who don't know about Devcon, so it is an annual conference by Ethereum, which is the world's largest blockchain ecosystem. So I was selected for this conference as a scholar among the 50 students around the world, and only two students from India, wherein I got a great opportunity to interact with the Ethereum ecosystem leaders and learn from them. Then I'm a blockchain developer and researcher, and I have an experience of around 2+ years in this domain, and sorry, I have taught 1,000 plus students on blockchain technology. Okay, so before starting with the webinar, I'll just clear out a few things about the certificate and the prizes. So, guys, I'll be announcing the exact details of the exact process at the end of the webinar. So just stay tuned in the webinar, and all your queries regarding certificates and prizes will be cleared. Okay, all right. So, to begin, first let us understand what blockchain actually is. So, if any one of you have any idea of blockchain, can you just write out in the comments? I'll just wait for a minute, and you can write out what do you understand by blockchain. You guys can write in the chat if you have any idea about blockchain. Okay, no problem. So I'll just give you a gist about it. So blockchain, if I were to tell you in a single line, so blockchain is a immutable distributed ledger. So let's break it down. So immutable. What do you mean by immutable? Immutable means once you put anything on blockchain, you cannot go and edit it. It is append only. You can say that. So how is it append only? So you can understand from the diagram, the illustration that is on the slide. So you can see various blocks connected via chains. So these chains have various cryptographic algorithms through which it is secured, right? So what happens is that once you write anything to a particular block, then you can't go and change that particular block. You can only add more blocks into it. The reason is every block is connected to the other blocks through a cryptographic secured, I mean, you can say that chains. So it is quite impossible to go back and change any block. So you can say that it is immutable, that you can only append things to a blockchain. Then it is distributed. That means it don't have any central authority that is controlling it. Right. For example, if you take any common scenario of any company, that let's take example of Amazon. So in Amazon, there's a central authority taking all the decisions, right? That whether whom to send, and if you are requesting for a refund, then whether it is right or it is they have to accept it or they have to reject it. So all those decisions are taken by a central authority. So in blockchain, there is no central authority. It is a distributed system wherein all the peers in the network, they themselves take the decision of how the network should move forward, and then it is a ledger. So talking about ledger, so you can understand it with a bank passbook. Okay, so it has all the transactions you have done in your in your bank. So it has all those transactions listed. So it is a similar ledger. I mean transactions when I'm saying, so it is not necessary that these transactions are like they are monetary transactions or non-monetary. Like everything on a blockchain is like done with the help of transactions. Okay, so I hope that is quite clear. Okay, so blockchain work on a peer-to-peer network. So you can see in the slide that on the left hand side we have like a traditional system wherein every client, every node is dependent on a third party, right, on a central service. But what happens in a blockchain is that as I already said, that there is no central authority. So everyone is directly connected to each other, which is called peer to peer. And the most common example that you will come across of peer-to-peer networks is your torrent. So like I guess you all must have heard about torrent if not used. So torrent exactly works on a peer-to-peer mechanism. So what happens is that there is no third party or no central authority in a torrent who is taking all the decisions. Like for example, you want to download a movie, so you are not downloading from the any server of BitTorrent, for example, right? There are like multiple peers in the network. So peers are the people. So suppose you create a account on BitTorrent, then you become a peer. Okay, so you only like they have multiple peers, and the peers only put on movies. So whenever you want to download any movie, so instead of downloading from from a particular location, you are actually downloading from multiple other peers who are offering their movies to you. Okay, so it happens like this in a peer-to-peer network. I hope it was clear. So let's see some of the perks of blockchain systems. Why do we actually use these kind of system? What's the fault in the current, in the existing centralized systems that are all around the world? So the first one is greater transparency. So transparency like is very important for us. So like for example, if I were to take a case of a bank. Okay, so suppose you just deposit some money in the bank, and then you don't know what is happening to your money. They can, I mean, they generally give it to some other people. They lend to other people and they earn from that interest, or they may invest in some other places, but you don't know what is actually happening to your money, right? For example, in the recent Yes Bank scenario, so like the bank just took a decision that your balance is freezed and you cannot take out like above a particular amount, right? So they are not actually very transparent. They were not very transparent like what actually is happening and all. So that is an issue. Then comes increased efficiency. So blockchain actually removes the need for middlemen, as we have also seen in peer-to-peer systems. So like there is no central server. So sorry so two peers can directly contact each other without the need of any third party. So it increases the efficiency because it is shortening the process. Okay, then there is better security. The security is better because it is like it uses very high level of cryptography, and since we have already seen that it is immutable, so it offers a better security than the existing systems. And then it is distributed. So since it is distributed, so it becomes like very difficult for someone to hack a distributed system. The reason being, if we talk about a centralized system, then the hacker have to only go and get into one server, and they can just get access to everything. But in case of a distributed network, so the hacker has to go to all the peers in the network, all the nodes, and they have to hack all the systems. So that becomes quite unfeasible, I can say. Okay, then improve traceability. So since blockchain is like immutable and it maintains a complete record, so at any point of time you can like completely trace any particular transaction. It doesn't matter that how long back in time it happened or like who did it. You can always track back any transaction or anything in a blockchain with a complete assurity that nothing has been tampered because it is immutable. And then accessibility, because we are no longer relying on a single server, so that if it, let's say, it goes down, then the particular service is not accessible. So it offers us these perks, but also there are many challenges in blockchain systems. Okay, so in this particular session we'll talk about the first challenge, that is reaching a consensus. The other challenges are scalability issues, lack of awareness, and low transaction speed. So we'll also like cover a bit of these, but mostly we'll focus on consensus algorithms. All right. So moving ahead, so this is like this illustration is just to give you a general idea of like blockchain system. So how does it how does things happen in a blockchain system, because there is no central authority. So you can as you can clearly see that there are 5 people in this particular network, and they all have their own blockchains. Okay, so they are storing their data on their own blockchains, and there, because there is no a central place where the master database can be stored. All right, so the problem that arises here is that how actually can they agree to a particular transaction or anything. I mean, like this is a small example. If we talk about hundred of thousands of nodes, hundred of thousands of people who are a part of the blockchain network who don't know each other, then they can't trust each other, right? So if like anyone is like putting on some malicious data on their particular blockchain, so other people cannot agree to that, and they don't have like much like they don't have much resources to check whether they are those things are malicious or not. So that creates a problem. So that's where consensus mechanism starts. So till now, if you guys have any issues, you can type out in the chat. Okay, so I don't think you guys have much issues just about the session timing. So with the session will go on till around 7:30, I guess. And at the end of the session, I'll be talking about how can you claim your certificates and like your prizes. Okay, so moving ahead. So what exactly is consensus? So consensus is like just a, you can say, a fancy term for agreement. So basically, if there is a group of people and they have to come to a common agreement. For example, let's take an example of us. So all the people that are watching this live and me. So like suppose we are on a network, right? And we have to come to a common agreement about anything. So how can we come to agreement? So that is consensus, actually coming to agreement in a group. So we'll see how can like how blockchains actually achieve consensus. So this is a traditional model of consensus wherein we have a central authority. In this case, we have taken example of a bank. It can be anything. So everyone submit their transactions to a central authority, and like they and the central authority takes care of if there are any malicious activities, or if there is any other problem. So it just oversees everything and comes out with a decision, right? But let's say in blockchain system, so there are no central authorities, right? So how will these transactions happen? So the first thing that comes to our mind is that suppose Gillian Gillian has done a transaction, then Gillian can just tell all the other nodes in the network, all the other, so nodes are just the other people who are in the network. Okay, so if you create an account on any network, on any blockchain network, then you become a node. Okay, so suppose Gillian just do a transaction and just like sends it to everyone that I have done this transaction. Please add it to your blockchain, to your personal blockchain. Okay, so this is one thing. But what problem this has is that suppose Gillian is like a like malicious. He wants to do something bad in the network. So suppose there is an attack known as double spend attack. So what happens in this? Suppose you have like 10 BTC, 10 Bitcoin in your like with you, and you double spend it. That is, you send the same Bitcoin to Nadir, and here Gillian is sending the same Bitcoin to Nadir and the same Bitcoin to Brian. Okay, so like this is a double spend attack when we are spending the same token twice. So this kind of things happen because there is no one to check that is this transaction correct or wrong. So this kind of things can happen. So what's the solution? The solution is a peer-to-peer validation. So what we can do is that instead of just accepting the decision, accepting the transactions whatever are coming to us, so we can verify. So in this particular system, what we can do is that suppose Gillian do a transaction, then Gillian proposes that particular transaction to the all the nodes in the network, and all the nodes will check that whether this transaction is valid or not. And once a certain number of nodes validates it, then only that transaction gets accepted to all the nodes in the blockchain. Okay, so this this is one solution that can be done using peer validation, and that certain number can be like anything. It depends on different consensus mechanisms. So generally it is like more than half. So if 51% of the people says that something is correct or something is wrong, then that is the final decision of the entire network. Then like this also has a problem. So what problem we are having is that, suppose that the Gillian creates multiple identities in the network, right? So here you can see that there were 5 nodes, and out of these five, 3 nodes are under Gillian. Okay, so like this can happen that you can create multiple identities. Now if Gillian wants to do double spend or any other malicious attack, then like it's very easy, because Gillian has more than half of the network with him. So he can do anything, and that will be accepted in the network. Okay, so these are some of the problems that distributed systems face. So we'll see how these are like being handled. So yeah, so this is called Sybil attack. This particular attack that I talked about of creating multiple identities, so this is called Sybil attack. Then comes Byzantine generals problem. Okay, so do you know about Bitcoin? How many of you know about Bitcoin? You can type out in the comments. Okay, I guess most of the people have heard about what Bitcoin is. So Bitcoin was like the first implementation of blockchain, you can say that. And like a lot of people believe that Bitcoin brought in proof of work, the consensus mechanism that started these things. But actually it is not true. So the concept behind proof of work and all the other things were pre-existing. So what Satoshi Nakamoto did was just accumulate those particular concepts, and actually implement them, because earlier those were just concepts, they were not being implemented. And just one new concept that was introduced was Byzantine's fault tolerant. Okay, so that is one very important property for all consensus mechanisms to have. So let's understand this with a very simple problem, which is called Byzantine generals problem. Okay, so just see in the left illustration. So what's happening is that there is a city in the center, and there are many generals around the city, and they want to conquer the city, so they have to attack it. Okay, now the generals are situated very far from each other, so it is not possible that sorry, it is not possible that we go with a centralized approach. Okay, so what we are doing in this is that we'll try to follow a distributed approach. And the other problem that is in front of the generals is that like the city has a very big army. So if only some of the generals attack, then they will not be able to win, so they all have to attack at once in order to achieve a victory. Okay, so you can clearly see in both the pictures that in one all are attacking at the same, and that is leading to victory, and the other one is in which half or maybe some of the generals are traitors, then it leads to defeat. So what can happen in this? How can they coordinate in this particular situation? So let's discuss about it. So suppose that the generals on the left hand side on the left hand side of the screen. So suppose they want to they decided that they want to attack on, let's say, on Friday. Okay, so they have to coordinate with the generals on the right side of the city. Okay, so what they will do is that they will send some messengers with the message that will let's say the message has attack Friday, and they can send the messenger to the right generals on the right side. And then suppose a lot of things can happen. Suppose when they receive the message, they were not actually prepare to attack on Friday, so they send again the message that no, please attack on Sunday. Okay, so if we talk about the real life scenarios, then what can happen is that maybe the messengers can get killed in between by the army of the city. Maybe the message get tampered with. So how can the generals on the other side know that what exactly, like whether this is the original message that was sent or it is tampered with? And in case that it is tampered, so it will lead to like an uncoordinated attack, and mostly that will further lead to a defeat. So how can we like take care of all these things? So we'll see in the consensus mechanisms. Okay, so this is just another illustration for understanding the same thing. So in the first, in the left one, so the lieutenant is a traitor. So the commander told him to attack, but he like said that he told to retreat actually to the other lieutenant. And in the second one, the commander himself is the traitor. So to one lieutenant, he is telling that attack, and to other retreat. So in this case, like the defeat will be there, and they will not be able to win. So we'll see how the consensus mechanisms are solving this. So this is a general like general table in order, like since we talked about Byzantine generals problem. So how is blockchain related to that? So as we talked about geographical distance, so in blockchain that you can refer to that as distributed network, and in here the generals can be referred to as nodes. The traitor generals can be referred to as faulty or malicious nodes, and the unreliable messengers can be like the messages between nodes that are dropped or that are corrupted. And these are the things. Attack or retreat means coming to a consensus. Okay, so like any questions till now? Okay, so one question is, are nodes minors or normal people? Okay, so like nodes are normal people, minors are also nodes, but they are a different type of nodes. We'll discuss about it when we talk about proof of work, but everyone in the network is called a node. Mm, consensus, can you please explain again? Okay. Okay, so just let me go back. I'll just quickly reiterate with it. Okay, so consensus, I think it was clear that we are like, see, first is the traditional model, then we did the normal approach, then we saw that there was problem in that anyone can double spend, then it was peer validation, that if every node in the network is validating every transaction, so it becomes easier. Then in that also there was problem that of Sybil attack, that maybe Gillian can create multiple identities in such a way that it gets a hold of maximum of the network. So in this case, like it becomes very difficult to handle the situation. Then it is Sybil attack, and then we came to Byzantine generals problem. So it is just a normal problem that in a real life situation, if people have to coordinate with each other, then a lot of things can happen. I mean, the messenger can get killed in between, or the message can be tampered with. So how can these things can be managed? Okay, so moving ahead, let's talk about consensus mechanisms in a blockchain. So with proof of work, as I will talk about proof of work, so a lot of things will become much clearer. So like there are many, like there are multiple consensus mechanisms, but in this session we'll talk about these main four mechanisms, which are proof of work, proof of stake, delegated proof of stake, and Zinfin delegated proof of stake. Okay, so let's start with proof of work. So let's understand proof of work with the Byzantine generals problem. So let's see how it solves. So what these generals can do in order to like prevent that the messengers get killed or like the message is tampered with. So what they can do is that they can like first they can get the original message. Let's say that message is attack Friday. Then in attack Friday, they append a nonce. So what is nonce? Nonce is a like it can be any random value, right? So they just take a random value. They can use a random number generator, or they can just think of anything random number in random number, and they can append it to that particular message. And together, that appended message, then they do a hash of that message. So if you're not familiar with hash, so hash is nothing but a simple you can say it is a simple function to which you can give any input. Like the input can be of any length. Let's say it can be of 1 GB or it can be of 1 KB, and it always gives a fixed length in output. Okay, and that is unique to every input. So it's kind of a password, you can say in layman terms, that it kind of an identifier or a password for your any file. It doesn't matter if it can be any like 1 GB or 1 KB or 1 byte. So it always gives the same length output. Okay, so what they do is that first they append a nonce to the message, then they create a hash of that appended message, and then they send that hash along with the nonce and the original message with the messenger to the generals. Okay, so how this hash is calculated? Now the question comes. So what, like it depends on various situations. So what can be done is that suppose the generals have decided that whatever the final hash value is coming, it must have at least 5 zeros in the beginning. It must start with 5 zeros. So in this case, like what the generals will do, the generals on the left side that are sending the message, they will hash it again and again, hash the message again and again by changing the nonce. So nonce was a random value, so they can just come up with another random value. So they will keep changing the nonce until a hash comes that satisfies the situation of like 5 zeros in the beginning. So this 5 zeros is like that can be anything. I'm just taking an example. So this entire process takes a very long time. Okay, it's a very complex process and it takes a very long time. And that's the beauty of proof of work that you will understand in a few further slides. And then suppose they sends the messenger with that particular message. So even if any soldier in the city founds the messenger and kills him or her and try to tamper with the message, then what will happen is that if he or she hampers with the message, then the hash will not be relatable to that particular message. Okay, because as I said that it is kind of identifier. So as soon as you change the message even a little bit, then the hash will not reflect to that particular message. And suppose they send it to the generals in the right side, then how the generals can verify is that since like the generals on the left have sent the message, the original message without hashing, the nonce and the hashed message, these three things to the generals on the right. So what they can do is that they can normally append that nonce on the message and hash it and check whether that hash value is matching with the value that messenger has brought. So in case those two things are different, so clearly someone has tampered with, so they will know that we should not trust this message. Now one more thing can happen is that the city soldiers can create another hash which satisfies their like the condition, that is 5 zeros in the beginning, and they can append the new hash with the message that matches with the new message and they can send it. But the problem with this how we can solve this problem is that the generals on the left hand side will not send just one messenger, they will send multiple messengers. So even if they catch one or two messengers and like try to create a new hash, then they will take a lot of time to create the new hash, since it is a lengthy and complex process. So by the time the other messengers would have already reached the destination and the attack would have already happened. Okay, so I think you would have got an idea. If the things are still unclear, it will become clear further as we go further, or maybe you can watch it again. Okay, so let's see in reality how proof of work works. Okay, So as I said that there is a hash puzzle included, right? They have to create a hash. So in for example, if I were to take a case of Bitcoin, so in Bitcoin what happens is that suppose we have to include a block in a blockchain. So the people that includes block in a that like puts or creates blocks and adds them to a blockchain are called miners. So as someone was also asking that what are miners and difference between nodes and miners. So nodes are every participant in the network, and these are special nodes called miners who actually add the blocks to the blockchain. So how they do it is that they solve a complex mathematical hash puzzle, as we saw in the Byzantine generals problem. So they solve a hash puzzle, which is not like complex in itself. The calculation is not complex in itself, but since it requires multiple iterations and it is a brute force computation, so it takes a long time and huge computation power just to do that simple calculations again and again. Okay, so the miners compete that whoever solves this puzzle first gets a chance to add a block to the blockchain, and whoever successfully adds a block to the blockchain gets some reward in return. That reward is like a fixed amount of Bitcoin if we talk about the Bitcoin blockchain, and for different blockchain networks it is different. So what is that hash puzzle? So as you can see on the screen, so hash puzzle is like exactly this. So first is nonce. We are appending nonce with previous hash. So this is the hash of the previous block in the blockchain, and then we are appending it with the Merkle root. So Merkle root, if you don't have much idea, so it's no problem. I mean, you can study about it. So in simple terms, maybe you can think that it is referring to the contents of that particular block. Okay, so we are taking nonce, hash of the previous block, and the contents of the current block, and we hash them. I mean, the miner hash them, and they keep on hashing it again and again by increasing the nonce, because the previous hash and Merkle root will remain the same. They will just keep on increasing the nonce because that is a random value, and they will keep doing it till the value is less than the difficulty level. So what is the difficulty level? So if we talk about Bitcoin, so difficulty level is like a number that is used to like manage how many blocks are being mined, what is the speed, and how much is the difficulty in other terms you can say. So for example, you can consider the difficulty level as a dartboard. Okay, so as we make the dartboard more smaller, so it will become difficult to hit the dart on the target, right? So similar is like difficulty level. So if suppose the level number is 100, I'm just taking a random example. Suppose it is 100, then and in other case it is 10. Then in the case when it is 100, it is much easier to find a value less than 100 because 100 is greater than 10. So there are more values less than 100, right? So more the difficulty level, I mean the more the value of the difficulty level, the easier it gets to actually find the relevant hash. And this difficulty level in Bitcoin, it is updated after every 2016 blocks. So after every 2016 blocks, it sees that how much was the difficulty in the previous blocks and how much time was taken, and it adjusts the networks as to the time comes out for every block is 10 minutes. So in Bitcoin, in every 10 minutes one block is added. Okay, so how this proof of work can handle Sybil attack? So in proof of work, as we have seen that we need a huge computation power, right, in order to add any block. So in case even if Gillian makes multiple identities, then like Gillian should also have a lot of computation power. And that computation power, if we talk about real networks, so suppose a network has hundreds of thousands of nodes, then doing a 51% attack in that particular network is very difficult, because 100,000 means that for 51% attack you have to have a computation power more than 50,000 people, and that's like quite unfeasible. So it's not possible in like generally it's not possible to do a Sybil attack in proof of work systems. But if we take example of smaller systems wherein maybe there are only 3 or 4 nodes or 100 nodes, then maybe it's like possible. Then comes 51% attack. This I've already discussed. That 51% attack is, although it's not feasible, but it is possible. Then come some of the limitations. So as we have seen that it requires huge computation power. So it is one of the limitation of proof of work, that it is very difficult to like add a block because it requires huge power and energy. And since it requires a huge amount of electricity, so it is bad for the environment, and it is quite slow also. Then what is happening is that people who have who have a lot of resources are able to manipulate the network. So this is a real stats of Bitcoin network. So you can see some of the major players manipulates the entire Bitcoin blockchain. So if you even if 4 or 5 of them comes together, then they can easily coordinate a 15% attack. So Bitcoin is, you can say, moving towards centralization. Okay, so before moving ahead, if you have any queries, you can put out in comments. Okay, so one question is, who decides how many nodes would be there? So Kamaljeet, so it depends. It depends on the network. Okay, so suppose for example, if we talk about public blockchains, so there can be any number of nodes. Anyone can create uh, an account on that particular blockchain. So suppose if you today, if you want to go and create an account on Bitcoin, on Ethereum, so you can do, you can become a node. And if we talk about other like private blockchains or other kind of blockchains, then the rights depends. Like if in private blockchains, whoever is like have the access, like for example, if it's a blockchain of a company, of a particular company, then that company can decide that who can become a node and who cannot. Is cryptography legal? Yes, cryptography is entirely legal. So cryptography was never illegal. It's just it's not only used in blockchain, it's used in like multiple places in your normal software development in order to attain security. And if you are talking about cryptocurrency, so yes, cryptocurrencies are also legal. They were never illegal actually, they were just banned for a certain period of time in India, but now the ban has been removed and it's completely legal to do anything. Please explain again about proof of work. Okay. Okay, Khushbu. So, like proof of work, you can simply understand it like in proof of work, if you need to add any block to the blockchain, so so anyone who is doing that, they have to solve a puzzle, and that puzzle is like requires huge computation power. And it's like as the name suggests, proof of work, that the miners have to show that they have worked, they have given some computation power for it, and whoever solves that puzzle first gets the chance to commit the block, and in return they get some profit, they get some maybe a Bitcoin or something else. So in simple terms you can understand it like this. Then can you tell blockchain real life application other than Bitcoin? Okay. Okay, so like Bitcoin is just Bitcoin was just the first use case of blockchain, but blockchain is like a much vast sea. You can say that if suppose if you take example of internet, if you say blockchain's internet, then Bitcoin is just one website on internet, and it has many other applications. It has applications in healthcare, in supply chain, in education, and in insurance and many others. So in almost every other sector, it has an application. And like many companies, many big companies like IBM, you can say, and there's one company called Mask, and like many other companies. So they are already implementing blockchain in various places. So you can just go and research about it a bit. Bitcoin is like nothing if we talk about use cases. Then what is the first step to get into crypto mining? Okay, so if you have to do crypto mining, so if you're talking about, let's say, Bitcoin, then you cannot do it on your normal laptops. So there are separate machines called ASICs, so you have to buy them for Bitcoin mining. And if we talk about other systems that do not require such large computation power, as we'll see further in the session, then you can simply mine on your, I mean, that will not be called mining, but it will be the almost same process, and you can do it on your laptop. Please suggest in system. Okay, so like if you guys want any help to learn more about blockchain and these stuff, so you can just join our Telegram channel. You can find the link in the video description, or you can search on Telegram Zubi_sub, and you can join our Telegram channel, and we'll be more than happy to help you if you want to learn more. Okay, so let's move ahead because we have a lot more things to cover. Okay, so let's talk about proof of stake. So proof of stake is like, you can say it is quite similar to proof of work, and the main difference is that it makes the entire process virtual and replace the miners with validators. So here there are no miners. The people who add blocks are called validators. Okay, so yeah. So how do we become a validator? So in order to become a validator, people have to put in some of their coins as stakes. They have to lock them up, or you can say freeze them, and that coins are just freezed and they cannot use them anymore, and they can become a validator. After that, they'll become eligible to create blocks and verify them. So once you become a validator, so how is it chosen that like which validator is committing the next block? So it is a randomized process. Okay, so if we are talking about the simple proof of stake, a lot of companies, a lot of people are working on it and modifying different things of it, but we are talking about the most simple approach. So in the simple proof of stake, a randomized process is used in order to determine that who is producing the next block. Okay, and in general, the person who has the most stake, who has staked the most number of coins, gets the highest preference to commit the next block, and whoever successfully commits the next block gets a transaction fee as the reward. Okay, so one question may be coming in your mind that like this is unfair that whoever is taking more coins gets more preference to commit in the block, in the blockchain. But why proof of work is doing it is because it believes that whoever owns most of the coins or more coins in the network, and whoever has staked more coins is more interested in keeping the network maintained. Okay, because if the network goes down, if they do any malicious activity, and due to it the network goes down, or any problem comes, or the value of the coins goes down, then it's like it's not in their favor, because they have staked coins of that particular network, and they want the network to, to move ahead, to stay maintained, stay stable, and the value of the coins to go high. So it is based on this particular approach. So what problem proof of stake faces is that there is a term called nothing at stake problem. Okay, so suppose you become a validator. Now you have to create blocks, verify blocks. Okay, so let's say in this illustration you can see there are two chains. So the blue chain is the, you can see, the original chain, and the red chain is another chain that that any malicious node is trying to create. Okay, so suppose you are a validator, so you can just bet on both the chains. You can say that let's say after block 53, block 54 in the blue chain is also valid, and in the red chain also the next block is valid. Because what approach you are following is that you just bet on every possible outcome, and even if any one of them is correct, then it's a win-win situation for you, right? So there is no loss of a validator if they validates any malicious blocks. So that is one problem, that the validators don't have anything at stake. So that is one limitation, the original proof of stake mechanism. But like as I said, that many people are working on it. So Ethereum is also like working on proof of stake. They are shifting from proof of work to proof of stake. And so what they are doing is that in case any validator validates a malicious block, then the amount that they had staked, that they had freezed before becoming a validator, so that is gone. I mean, that is burnt, or a particular percentage of from that amount is cut, so that there is like a consequence if you are promoting wrong activities. Okay, so this is just a general like a differentiation between proof of work and proof of stake. Most of the things we covered, that just some few more things. That proof of work is quite slow. The transaction rate is quite slow because it requires huge amount of computation power and everything to be done before committing the next block, as compared to proof of stake. So in this, the transaction rate is pretty high, and it is like more environment friendly than proof of work because it don't require this much electricity. Then comes delegated proof of stake. Okay, so before this, I'll take some more questions. How can we take practical knowledge about blockchain concepts? Okay, so Himanshu, you can like first get a basic idea of the theoretical concepts of the blockchain, and then you can delve deeper into blockchain concepts. Like there are many blockchains out there, Ethereum, Bitcoin, like you can say thousands of blockchains, and you can pick any one up and you can start development. Mostly people start with either Ethereum or Hyperledger, so you can start with Ethereum, and you can join our community and we'll be happy to share. In fact, we have various resources on made of our own, and we can share on our community. Okay, our hash is used to check if the block is valid or not. Okay, so like in order to check that whether a block is valid or not, so actually we'll have to talk about the components of the block. So in each block there are multiple transactions. Okay, and in order to validate a block, so anyone has to validate all those transactions. That whether those transactions are like correct or they are wrong. If anyone is trying to do any double spend attack or anything else, so for that different softwares come and there are different approaches. So with that you can validate. Hello, someone is saying sound problem. Is my voice clear? Hello, if you can just put a yes on the comments if my voice is audible. Okay, I think it is audible. Okay, let's move on to the next question. What if two people have simultaneously committed transactions? So which one blockchain will commit? Okay. So the first thing is blocks are committed. I mean, blocks are added. So transactions are just a part of those blocks. So what happens is that let's say there are million nodes on the network, and all are doing
Yeah, Yogesh will be joining us soon. Please stay connected.
hello.
Yeah, Yogesh is here.
Am I audible? Just give me a minute.
Yeah, Yogesh is here.
Puneet, is my voice clear?
Yes, Yogesh.
Okay, just give me a minute. I'll just add on my screen. Okay, so I think now I'm audible. Okay, great. Apologies for the inconvenience. So what I was answering one question, that what if two or more people commits a transaction at the same time? So the first thing is transactions are not committed like this. So let's say, for example, we have like multiple nodes in a network, and all are doing some transactions. Then those transactions goes to a pool. Let's say it's just they get just stored at a separate place, and then the miners come and they pick those transactions and form a block. Okay, and then when they form a block, then they have to commit that block. So it may happen that two or more people have committed the block at the same time. So in that case, both the blocks will be accepted. Sorry. So in that case, what will happen is that both the blocks will get accepted. They will just form a parallel chains. So as we saw in the example, just give me a minute. As we saw in this particular example, that there are two chains emerging from a single block, right? So if let's say the block 51, for block 51 two people committed at the same time, so both these blocks will get added in the similar fashion as shown. And then but only one one chain is like finalized. So what happens is that it depends on the network. So suppose, let's say that block 51 is added for both the chains. So it's the choice of the network. So the network will analyze both the blocks, and they will see that in which particular chain they have to commit further. All the miners who will be committing after that, they will validate these two blocks, and they will see that on which they have to proceed with their block. And then after some time, whichever chain is the longest, that chain is considered as final. Okay, so it may happen that for a time being there are two chains, but finally there will only be a single chain. The longest chain is the single chain. Okay. Okay, so the duration of the session will be like it will go on for another half an hour at max. I hope that solves your problem, Niharika. Explain in detail about validators. Okay. Okay, so validators, so it's like very simple. They just have to stake a particular amount in order to become a validator. Once they become a validator, then they will like all suppose we have five validators. Okay, then all of the five validators will try to commit the next block, and whoever then there is a random algorithm that goes on. So that random algorithm gives more preference to the people, to the validators with more stake. Okay, so according to that random algorithm, a particular validator's block is chosen and that is added. How to differentiate between blocks while doing validation? Differentiate as in, I mean, I'm not able to get your question properly. Differentiate between blocks while doing validation. So like for validation, they create the block, and they propose the particular block to the network, and whoever's gets selected, they that is added. So if the longest chain is removed, then the transaction. Yes. So if the non-longest chain is removed, then the transactions of that block is also lost. So that is why what happens, that if I take example of Bitcoin again, then generally after the transaction is like added in the blockchain, then it is said that you have to wait for a particular time, at least 3 to 4 blocks to get added, in order for the transaction to get confirmed, because there is a chance that that chain can be rejected. So yeah. Yes, validator is a node handler. Okay, so I'll just continue from here. Like my apologies, guys. I'm not able to take all the questions. you are most welcome on the Telegram community, or you can ping me on LinkedIn. I'll share my LinkedIn links after this webinar, and for the Telegram link, you can see in the video description. Also, like if you are finding this video fruitful, feel free to subscribe to our YouTube channel so that you can get notified whenever we are coming with a new video. Okay, so that being said, okay, so let's talk about delegated proof of stake. So delegated proof of stake, you can say, is just a kind of a extension for the proof of stake mechanism. Okay, and it is kind of a digital democracy. So for example, in case of a democracy, you select some leaders and you vote those particular leaders, and according to the votes, like a person is chosen, and then they take decisions on your behalf, right? That since you have chosen them, maybe the prime minister or anything, then they take decisions for benefit of everyone. So it is quite similar. So what happens is that in delegated proof of stake, there are nodes called delegates. So delegates are the people who will actually produce the blocks and add them to the blockchain. And how they are chosen is that all the nodes in the network, they vote. You can say they vote for specific delegates, and they put some stake. Let's say I put 10 BTC, and I say that my vote goes to maybe Rohit. Okay. And someone else can say that I stake 5 BTC and my vote goes to Rahul. Then the vote which has more stake, that is my vote, which had 10 BTC, as compared to the other one which had 5 BTC. So that has more weight. So the weight of the vote depends on the stake, right? So all the nodes have to vote to the delegates and put in some stake, and according to the stake, the weight is decided. And at the end, whoever gets the highest weighted votes, they they are like selected as the delegate. So like there can be different number of delegates that depend from network to network. So generally, there are a group of delegates who have the highest number of votes. Let's say maybe 100 delegates. The highest voted delegates are selected, and they are granted the right to produce the blocks on the blockchain. Okay. So like again, like among these delegates, there are multiple approaches through which a delegate can be chosen. That can be a randomized approach or any other approach. So there are some of the like issues in this particular approach. So the one issue is like it is moving towards centralization, because if we see earlier in proof of stake or proof of work system, when there were, let's say, thousands or hundred of thousands of nodes were coming to a consensus, now there are, let's say, just 100 nodes who have to make the final decision. So there is a possibility that they are corrupted in some way, like we generally see in the normal democratic system around us. So that's a possibility. So it is quite more centralized than the previous two algorithms. But the like the benefit of this DPoS, delegated proof of stake, is that it provides more speed. Why? The reason is that since less number of people have to come to a consensus. Earlier, everyone have to come to a common consensus. Now only 100 or whatever the number is, that number of people have to come to a consensus. So like lesser number of people means it takes less time to come to a consensus. So obviously it has a speed advantage. That's why it is like very popular these days. Then comes Zinfin delegated proof of stake. Okay. So in Zinfin delegated proof of stake, like the major aim of this algorithm is to reduce the energy consumption and improve the scalability of blockchain networks. So let's understand that how the mechanism exactly works. So what happens in that, it is quite similar to proof of stake in the thing that each token holder have to stake a particular like each node have to stake a minimum amount of tokens in order to become a master node. So in this in proof of stake, we were calling them validators. So in this, these are called master nodes. So in order to become a master node, you need to stake a particular amount of tokens. There is a minimum amount. You can always stake more than that. And then those master nodes can create and verify blocks in a round robin fashion. So in this particular algorithm, out of all the master nodes, the final master node who will create the next block is chosen in a round robin fashion. Okay, and then one more important feature of XDPoS is that all the master nodes in this should be KYC verified. So it supports a self KYC feature so that you can easily get yourself verified, and it has various benefits. Like in case, like for example, if let's say that we have a banking system on blockchain, then all the master nodes or all the validators who are validating or creating blocks, all the people must know that yeah, they are trusted people, and we can trust them with the rights to add more blocks. So that is why they have included the KYC feature so that that trust continues. Okay. Then there is one thing called double validation in XDPoS. So what is double validation? It is like okay. So we have discussed that master nodes create a block and they're selected in a round robin manner, right? So what happens if a master node is faulty or it is malicious and they put in some wrong transactions in the particular block? So in order to tackle that, double validation is there. So as soon as a master node creates a block, so another master node is selected at random from the pool of the master nodes as a verifier. So that particular master node will have to verify that if the block created by the previous master node is valid or not. So that increases the security in the system and removes any chances of any malicious activities because it is getting verified directly. Then comes underperforming master nodes. So a condition may come wherein these master nodes, let's say 100 master nodes, some of them may be underperforming. They are not creating blocks or they are not verifying blocks. They have just become a master node and they have closed their system or whatever and they have gone somewhere. Okay, so this condition may occur. So how do XDPoS handle this? So first, let's see that some other important features before coming to that. Okay, so there's a term called epoch. Okay, so it's basically a time period, and different networks can define it accordingly. So in XGPOS, epoch is a period in which a maximum of 900 blocks are created. Okay, and if we talk about the speed, then every 2 seconds a block is created in XGPOS. So in Bitcoin, we have seen that in every 10 minutes one block was added, and here every 2 seconds a block is added. So you can imagine the difference in the speeds of the transaction. We'll come to the actual number soon. Okay, so what happens is that if any master nodes are underperforming, they are not performing their duties, then it significantly decrease the performance of the whole network. Why? Because if they fail to create a block when they have the turn, then the entire network have to wait for 10 seconds before the next master node takes its turn and create the next block. So if we are just talking about one, one underperforming master node. If we talk about multiple underperforming master node, then it becomes a significant time delay. So there should be a process in order to handle those. Okay, so there is a process that is called slashing mechanism. So what happens is that in case a master node is not has not signed or has not created any block during an entire epoch, that is 900 blocks. So what will happen is that that particular master node will be slashed off from the from the master node position for the next 4 epochs. That is next 3600 blocks. And meanwhile, while they have been banned or slashed off, they can still verify and they can create blocks, but they will not be incentivized for that particular action, right? So they will be like banned or suspended, and they can still perform their actions, but they will not be incentivized. So that is the consequence if you are like underperforming master node, and if they want to become a master node again, then what they will have to do is that during that suspension period, they still have to sign and verify blocks even if they are not getting any benefit out of it, so that the system can check that yes, this master node is now active again, so we can include it, right? So this is the slashing mechanism. So what are the perks of XDPoS? So the first perk is like energy consumption. So as we have already seen that proof of work systems specifically requires high amount of energy, right? So as compared to proof of work systems, so XDPOS only consume around 1/10 of energy. So that's a plus point. Then it has near to zero transaction fees. Okay. So generally, if we talk about these Ethereum or Bitcoin, then they include high level of transaction fees. So why they require high level of transaction fee is that one thing is, yeah, okay. So if I were to take example of Ethereum, or maybe, okay, let's leave Ethereum, let's take example of any proof of stake system. Then in that, the validators were getting transaction fee as rewards for validating, right? So they will choose those transactions with higher transaction fees. And similarly in case of proof of work, so people generally put large transaction fees and all. So and the network also charges transaction fee as a base transaction fee in order to compensate the validators or the miners. So they have high transaction fees. But in XDPoS, we have like near to zero transaction fees. So we can even do our micro transactions. So for example, you are sending your friend maybe 50 rupees or 100 rupees through Paytm, right? If we talk about general proof of work systems, let's say, then it will not be feasible to send that amount because you will have to pay huge amounts of transaction fee along with it. So generally large amounts of transactions are done through it. But in case of XDPOS, so even these small transactions can be performed. Then there is self KYC based node solving problem of anonymous network members issue that we have already discussed, that it is provides a hassle free features to do a self KYC and get verified. Then it solves the scalability problem of low number of transactions, and it has a high transactions per second. So the reason is the same, because everyone in the network don't have to come to a consensus, only the master nodes have to decide. So that's why its speed is like very high. If I were to compare between Ethereum and Zinfin, then Zinfin has a speed of 2000 transactions per second, and Ethereum has 15 transactions per second. So that's a huge difference. So, and then Zinfin is KYC enabled, Ethereum is not KYC enabled. Zinfin has near to zero transaction fees, and Ethereum has comparatively very high transaction fees. And Zinfin is like environment friendly, and Ethereum, which is like based on proof of work, is not environment friendly. So Ethereum is also shifting to proof of stake. The shifting has begun. Okay. So these are some of the important links for like XDPoS, Zenfin Hybrid Blockchain Network. So you can go through these links to, in order to get to know more about it, and you can join their Slack community to, if you have any queries or if you need any other resources. Then, as I said in the beginning, that the four mechanisms that we discussed, those were just a few of the many mechanisms available. So there are like numerous, I can't even count them. So these are just more four mechanisms. I'll just give a one-liners on them just to give you an idea that like how different mechanisms are there apart from them. So the first one is proof of capacity. So the proof of capacity is like similar to the ones that we discussed, like proof of stake or proof of work. Just the differentiating factor is that it depends on the amount of hard disk space in your system. So the more hard disk space you have, the more chance that you will get to commit the next block. Okay. Then comes proof of elapsed time. So it depends on how much time you have waited in order to commit a block. So if you have waited for a longer time, then your chances increase to commit the next block. Then proof of burn. So proof of burn is like exactly similar to proof of stake. The only difference is that in proof of stake, the amount that you are staking gets freezed, and you can release it whenever you want to, like step down from the position of a validator. But in this, whatever amount you are staking, it gets burned. that means that is never coming back. Okay, so that's the only difference. Then comes proof of authority. So in proof of authority, instead of any money or any token, your authority is at stake, and more the authority means more chances of committing the next block. Okay, so like in concluding it, so I'll just say this one thing, that although we have discussed quite a few consensus mechanism, but it's not like some like one is better than other. Every mechanism has its own perks and limitations, and there are different situations in which these are applicable and these were created, so that fits perfectly for their particular situations. Okay, so I'll take more questions now. Okay, while people adopt Zinfin, if they aren't incentivized like BTC to join it. Okay, Mukul, so people are incentivized. Like everyone, like every miner or validator or any master node, whenever you commit a block, you get incentivized in some way or the other. That depends on network to network, that how people are getting incentivized, but everyone is incentivized. Hope that solves your problem. Okay. Which blockchain platform is good to learn the blockchain? Okay, so Khalil, so like as I said, there are multiple blockchain platforms. You can opt for anyone in order to start. Like there are, as we today talked about Ethereum, Zenfin, and others. So you can start with any one of them. You can start with Ethereum or maybe Zenfin, and you can get, see, the main thing is to get your concepts clear. When you have your concepts clear, and if you know even one blockchain how to code in it, then switching will not be much of a issue. It's just like changing languages. Okay, then okay, quiz link here. Just wait for a few more minutes after clearing the question. So I'll just go to the quiz and certificates and all. Feedback form, yeah, we will share. Mm, since every miner is making his own block with transactions in it and only one is chosen to be added, so how is it made sure that no transaction detail is left out? Okay, so like it may happen. So see, as we have discussed, that there is a pool of transactions, right? And miners choose from that pool that which transactions they want to put in their particular block. So it may happen that there is a transaction which don't get added to a blockchain for a very long time. So for that, the I mean the ideal solution to that is, like while doing transactions, you can put like you can customize the transaction fee. Okay, so you can put more transaction fee or more rewards that the miner will get. So the miners will choose those transactions in which they will get more reward. Right. So if there is a transaction which has very less rewards, then there are, yes, there are chances that it will take a lot of time before it actually gets into the system. Is there any efficiency as blockchain? Okay. Is there any similar application which works with exact efficiency as blockchain? Okay, so as blockchain, first of all, like blockchain is not an application; it's a technology. So yeah, there are few other, like you can Google Hedera Hashgraph. They are doing something which is like similar to blockchain, but quite different in some aspects. So you can check them out. Proof of stake says low returns. Why will validator put some stake? Okay, so yes, proof of stake has lower returns than proof of work, but there's a trade-off. See, in proof of stake, you just have to stake an amount. You have to freeze them. That is always present. You can anytime step down from the validator position. You will get that amount back. Okay, so that's why proof of stake has less returns, have less incentives. But in proof of work, what is happening is that even if you're trying, even if your block is not getting accepted, then also your computational resources are getting used, right? So in proof of stake, like a more incentive is given because the process requires more computation power and more resources. But as compared to proof of stake, the incentives are low because at the end the tokens are not going anywhere, they are just freezed temporarily. Okay, I hope that clears your doubt. Then, mm, how did you got Defcon invitation? Okay, so Ritik, although it's a bit like off from the discussion. So actually, I'll just give you a brief. So actually, the scholarship application comes out every year. So this year, the DEFCON 6 was cancelled due to COVID. So it's happening next year in Colombia. So the scholarship applications comes out and you have to fill them. And then they just choose you. So that's it for the process. Okay, so Azim is asking the presentation doc to study. Okay, so I'll share this presentation on the Telegram community. So you can join the Telegram community. Its link is in video description, and I'll share this particular presentation. And if you guys have any other doubts that I may have missed, you can always contact me on LinkedIn or on Telegram. Then can we develop an AI-based consensus algorithm? Yeah, for sure, Shivam. You can develop an AI-based consensus algorithm. I mean, see, there are these emerging technologies, AI, blockchain, IoT, cybersecurity. In itself, they possess they have huge potential. But if they are combined, then you can't even imagine that at how much heights they can achieve. So obviously, we can always combine AI with blockchain, with IoT, and other stuff. Then blockchain possibilities in COVID situation. Okay, so blockchain has a lot of possibilities for COVID situation. So one thing is to actually track back, since we have discussed in the properties of blockchain that it's easy to trace and it's immutable. So it's easy if we can establish a network on blockchain wherein people who are COVID positive or maybe who have some symptoms can put up their details and they can easily be tracked back, and everything can be done in a secured manner that it's not getting hacked or there is no central authority who can mold the data or do something. So yeah, you can do it, and in fact, I'll suggest you that there are many blockchain hackathons specific to COVID that are happening. So you should join them and develop some applications that can be used in this situation. In if in proof of stake, so Vinay is asking, in proof of stake, if two nodes has equal number of BTC, then what will happen? Okay, so BTC was just an example. So for Bitcoin is not a proof of Bitcoin do not follow proof of stake. But I got your question. So if suppose that in proof of stake two people have staked the same amount of tokens, so they'll have the same amount of preference. I mean, it's a random algorithm anyway. So they'll have the same amount of preference. Anyone can be chosen. The quiz link, Kausalya, I'll share. Just wait for a minute. Then more questions. Does blockchain also include coding? Yes, Aditya. Yes, it includes coding. And this was just explaining the consensus mechanisms. If you actually go and develop these consensus mechanisms, or if you build apps on the already existing consensus mechanisms, then all of these things requires coding. And you can maybe check out more the more events, more sessions on our YouTube channel. We have some wherein you can learn more about blockchain, and on our community we have various resources with which you can start. And in fact, if I were to give you a sneak peek, although it's not yet announced, but we are also announcing a blockchain elements course soon. So you can stay tuned on our Telegram community and you will get all the details. Okay, then yeah, Shivam. So you can if you have any particular idea in mind, so we have a GitHub repository, so you can just post there about your idea. You can propose your idea, and we'll be happy to work together with you. Okay, so I think most of the problems are solved. Most of the queries. Okay, so some of them are remaining. Can we write MOU for business agreement in blockchain? Yes, Kiran. for sure. So there are, if you have heard about smart contracts, so you can write MOUs and these things in blockchain. So these smart contracts will be autonomous agents. So they will automatically trigger when the appropriate situations that were coded in them becomes true. So that's actually quite helpful for creating these kind of things. Which language is best for blockchain? So Jeet, there are many languages. So what I will say is that if you are to start with blockchain, like personally, I started with Ethereum. Okay, so you can start with Ethereum. You can go through some of its basics. You can watch some videos, read some articles, and after you have the basics clear, you can also find some videos on our YouTube channel on those concepts. And then once those are clear, you can move on to smart contract development, as I just mentioned. So in smart contract development, there's a language called Solidity. So you will use that language to develop smart contracts, and then if you have to develop decentralized applications, then like it's like your normal web applications, you can use maybe Node, React, and other things, and then you can connect it with your smart contracts and use some other tools like Web3 libraries and all, and you can create a D app. And if you want to go into the consensus side, if you want to develop a new consensus mechanism maybe of your own or these kind of stuff, then there, that's a different field. That's called the protocol development field. So you can go in that, and maybe you can start with Golang. You can start with that. Then Ritik is saying that consensus involves a certain level of randomness. So yeah, Ritik, it involves a certain level of randomness. So the randomness is there so as to assure that no one can just figure out a particular algorithm, that how it is working, and accordingly maybe fault, maybe make those nodes faulty if they come to know that, yeah, this is the consensus mechanism, and after this particular node, that node is going to create the next block, then maybe they can do some sort of hacking or something. So it is kept random at purpose. So Madhusudan is asking, all the participants get certificates. Okay, so like for certificates, yeah, we'll have a very short quiz of 10 minutes, and you can have multiple attempts at it. And if you have heard in the webinar, if you were listening, not hearing, so you can very easily get that quiz and get your certificate. Voting application. So Arnav is asking, do online voting application can online voting application be built with blockchain? So yes, online voting application can be built, and like one of the, it is one of the most popular blockchain use cases. So you can see about it, and if you're interested to develop it, as I've already told, feel free to put the project idea in our GitHub repository, propose the idea, and we'll be more than happy to involve, like work on that project with you. Mm, explain the benefits of blockchain in terms of jobs. Okay, so for talking about jobs in blockchain, so like believe me, so you can get a lot of jobs even as beginners in blockchain. The only thing that is required is that you have the context, you actually understand how blockchain is working, because there are a lot of people who are just who have just started into development, and they don't have any idea about what blockchain actually is. So if you have the proper context and the relevant coding skills, so you can like easily, I'll say easily get a job if you have those skills. So there are many opportunities in the blockchain space, and it's continuously growing as we speak, because it's an emerging technology job, emerging technology. And if we talk about the future, then these technologies only have the future. All those other technologies that like if we talk about simple web development and all, then already AI, various AI applications are taking over it, where you don't have to code anything and everything is pre-built and other things. So the future is these emerging technologies, so you can invest in these. Okay, so like I'll not take any further questions. You can message me on Telegram maybe. So So I'll just share the thing about the quiz. Okay, so to claim the certificate and the prizes, so the process is like this. You have to go to https ss.zubi.io. The link is also in the video description. You can see there, and you have to go to this particular website. You have to sign up on the platform. So this is Zubi's own assessment platform. You have to sign up there, and then like many assessments will be available, will be visible to you. So you have to choose the consensus and blockchain systems assessment. So that has 20 questions in it, and it is a 10 minutes quiz. So it's very simple. You just have to go and give 10 minutes, and in case that you don't get passed in the first attempt, then you can give multiple attempts. So you have 3 attempts to it. So you can give that, and as soon as you pass the quiz, so you get a certificate. So passing criteria is 35%. Okay, and like for the prizes, so the prizes will be given from this quiz only. So whoever is the best performer in this quiz will choose the top 3 people and will give them the prizes. So I think you already know about it. So the first one will get 1000 INR worth of XDC token. The second one will get 600 INR worth of tokens, and the third one will get 400 INR worth of tokens. So we will decide that on the basis of the quiz, and whoever are the winners, they will get the further information about claiming the prize accordingly. Okay. So as I've also mentioned before, that I will share the slides, and if you have any other queries, then please join our Telegram community. I'll share the slides there only. So you can just see the link. It is https:/zubi_sub, or you can just search zubi_sub on Telegram, or you can also find the link in the YouTube description of the video. And do join the Telegram community. So that was all. You can follow us on YouTube. You can subscribe to our YouTube channel, so that you get updated whenever we have anything new coming up, and you can join our community. And if you have any further queries, you can find on Telegram from the community group, or you can approach me on LinkedIn. So my LinkedIn handle is visible to you. You can approach me on LinkedIn, or you can mail me also. Okay, so that was it for the session. Thanks a lot for joining today, and hope it was a fruitful session for you, and you got to learn a lot of new things. And we'll soon share a feedback also, and you can suggest that what are the topics you want further lectures on, and we'll be more than happy to assist you. And as I said, we are soon launching a course on blockchain elements, so you can stay updated on our Telegram channel. Okay, so that was it. Thanks a lot, guys. Have a nice day. Bye.